Hello everyone, this is Grade 6, Module 5, Lesson 2 problem set. The directions for the problem set say, calculate the area of each right triangle below. Note that the figures are not drawn to scale. So what we want to do is identify the formulas for area of a right triangle. And the first formula that we have is A equals 1/2 times base times height. And you probably don't see it with the two dots in there, but I like to separate them out so I know I'm doing multiplication. The other way that you might have been shown is base times height divided by 2. Because when we take half of something, like we do in this first one, it's really the same as dividing by 2. So I'll be jumping back. I'll do one with the first formula and one with the second formula just to kind of help out so you can see both sides of it. But either formula will be good for the set. So what I want to do for one is the first thing I'm going to do is write down my formula. And I have to identify my base and my height. And I know that my base is going to be right here. And my height is coming up from the base because it makes a perpendicular line segment, meaning it's going to make a 90-degree angle. So that's got to be my height. This is just the measure of the other side of a triangle, the hypotenuse, that we don't really need for area, but it comes in handy to find perimeter. So let's plug in. I still have my area is 1/2. My base is 9 1/10 centimeter. And this is where it's important to make sure that your multiplication symbol, your dot, is halfway up because I'm working with decimals right now. And I don't want to get those confused. And then I'll plug in my height of 31 2/10 centimeters. So my first step here is I have to decide what I'm going to multiply or do first. I can take half of any of these numbers, or because of the commutative property, I can multiply these two numbers first. And that's what I'm going to do first. I'm going to multiply my 31 2/10 times 9 1/10. And I'm going to go through and multiply just like I normally would. And my trickiest part of this is going to figure out where to put the decimal point in this problem. Because since I'm multiplying out a few two different decimal ones, I have to know that where I'm going to place this in my answer. And there's probably a little trick that a lot of people do, and that's pulling out the decimal point and then putting it back in, or counting your decimal places. That's a good way to do it if you know why. So I'll take a second and show you that. When I'm talking about 2/10 and 1/10, I'm talking about tenths. And I know that I'm multiplying those, so if I do a tenth times a tenth, I get 100th, meaning 2 decimal places, which is why I can come back and put it in right here, which is the same as what you're doing. You're counting 1, 2, and then jumping 2 back in. We're not really pulling the decimal out. We're just figuring that I have a tenth and a tenth, so that means I have to go to the 100th place, which is why I can count back 2 places right there and put it in to make sure that I have a 100th decimal place. So that tells me how far into my decimals I need to go. So just for a quick example, if I did this and I were going to multiply those, I have 100ths, because I'm talking about hundredths here, on the top, and I have tenths here. And if I multiply those, I'm going to get thousandths. Well, 1, 2, 3. 3 decimal places back. This is the thousandths. So that's why it's okay to pull those out if you understand why, because I'm doing hundredths times tenths to get my thousandths of a place value. That's just showing you when you have different ones here. We don't need this for right now, but I did want to show you why that works to count your decimal places. You're really multiplying a tenth by a tenth to get to the hundredths place. So I'm not quite finished here with my 283 and 92 hundredths, because now I have to take half of it, meaning I need to divide it by 2. So I'm going to come further down here, and now I just have to divide this by 2. And I know when I divide, I'm going to bring my decimal point straight up, and I always like to draw little dashes here where my numbers are going to go. Those aren't decimals, those are dashes for me to make sure that I have 3 digits before the decimal and at least 2 for after. So I'm going to solve that out now. And 2 goes into 2 one time, and I'll subtract that out. Let me see, I'm going to have to move down. And I'll bring down my 8, and that goes in 4. Goes in once. And now I'm into my decimals. And luckily this is going to come out A-OK, meaning I don't have to add any placeholders. So I have 141 and 96 hundredths. So I'm going to write that in. I have 141 and 96 hundredths, and now I need my units, and I was talking about centimeters, but since I did centimeters times centimeters, it's centimeters squared. So that's my area. Now, that was a long problem. So let's go over to 4. And I'm going to slide down a little bit so I can work down below. And I'm going to start with my formula. And for this one, I'm going to do base times height divided by 2 or over 2. You can still stay with the same formula if you want. So I'm looking for my area. I know my base is going to be right here where the 11 is, and my height is going to be 60 because they form a perpendicular set of line segments, meaning there's a 90-degree angle right there. So I'm looking for that, and I'm finding those. So I have my base is 11 millimeters times my height of 60 millimeters, and that's all divided by 2. So now I got to multiply 11 and 60. And I'll get 660. And it's not just 660, it's 660 millimeters squared because I did millimeters times millimeters. And it's divided by 2. And that one I can do right in my head, because half of 660 is 330, and it's still millimeters squared. Now, looking back up just a little bit through this page, we see we have some fractions, and we see more decimals. So make sure with your fractions, you have a couple different strategies that you can use to solve those. One of them being turning to fractions greater than 1 or improper fractions. But you're still going to want to use the formula A equals 1/2 base times height, or A equals base times height over 2. Let's take a look at page 2 real quick. And on this page, we're going to look at 6 and 7. And I'm not going to really do 7, but we're going to talk about it so you can do your explanation here, because I see that you're going to have to explain something. So 6 says, Elena has 2 congruent rugs at her house. She cut one vertically down the middle, and she cut diagonally through the other one. And we can see that here. We have a vertical one and a diagonal one. After making the cuts, which rug, labeled A, B, C, or D, has the greater area? Explain. Well, I know that when I cut this in half, I have half the rug here and half the rug here. When I cut diagonal on a rectangle, and I have a 90-degree angle, meaning a right triangle here, I know that this is half. It's half of the rectangle's area. So if I found the area of the whole rectangle and cut it in half, because there's my base, there's my height, I know that this is going to be equal to half of it. So that's half. So as from the labels, we can clearly see that A and B are the same size rugs. Or 1 and 2 are the same size rugs to start. A and B are equivalent because they're each half. C and D are equivalent, so they're each half, meaning A, B, C, and D are all equal. And it's because of what we just discussed that when we take and create a diagonal here, cut, and make a right triangle, the right triangle is going to be equivalent to half of the rectangle. Now the last one, 8. If the area of a right triangle is 9/16 square feet and the height is 3/4 feet, write an equation that relates the area to the base and the height, and then solve the equation. Well, I know I'm talking about area. Now I want to plug in. So I have 9/16 is my area. It's right here. So I'm going to plug it in for A. And I have square feet. That's going to equal 1/2. We don't know the base yet, but we do know 3/4 feet is the height. So now, what I need to do is I need to combine my like terms. So I'm going to take half of 3/4, and then I'll be able to use my equation solving from there. And I know multiplying 1/2 times 3/4 is going to get me 3/8 because I just multiply numerators, then multiply denominators. So 9/16 square feet equals B times 3/8 feet. Now I can use my inverse operation to get B by itself and solve. So I'm going to do the opposite. Instead of multiplying, I'm going to divide this 3/8 over to this side. So that should get you set up for number 8. I hope this helps. Thanks for watching, and good luck on your problem set.